Um, what are the Suvat equations and how to apply them is one of the skills that in physics we use a lot. Okay, maybe for some stages, maybe if you're in a university, you don't call them Suvat equations, but if you're working, for example, in an IB program, or you're working at school, it's usual to use the name Suvat equations in order to talk about any kinematic problem that involves accelerated motion. Okay. So we're going to solve a situation using Suvat equations as an example, so you can test the strategy in order to solve situations using Suvat. So let's go. I want that you check the following information. So imagine that you have a ball with at some height h, and I can throw the ball at 2 meters per second. So I throw the ball up at 2 meters per second, and with a stopwatch I measure that the ball takes 3 seconds to go from this point, from the point in which I am checking this point, okay, to the floor. So it takes 3 seconds. And my question is, what is the height of the building or the place in which I send ball, and what is the velocity that the ball has when it reaches the floor, okay, when it reaches ground. So the first thing I recommend for you to do anytime you apply Suvat equations is to write Suvat. That's why it's called Suvat equations, okay? Because first thing you have to do is to check all the variables you have in order to determine what is the answer. S stands for displacement. So in this case, the displacement, I'm going to use this green one. Displacement, okay, I don't think you can see it properly. Let me this. Okay, the displacement is this distance, okay? It starts on this position, finishes on this position. So the displacement is this distance that in plain terms will be negative h. Okay, remember that displacement has direction, so you should put positive or negative. Okay, so negative h. Now u will be the initial velocity, so I stand here, the initial velocity, 2.0 meters per second. V stands for final velocity, that is one of the things we wanted to know. A stands for the acceleration. In this case, it's motion according to gravitational acceleration. So we're going to use 9.8 meters per second, per square second. Okay, and time, T stands for time, will be 3.0 seconds. Okay, now we have this information, and with this information, we're attempted to find out the unknown variables. So now what I recommend is for you to have a table of the Suvat equations, and using this table, try to find out which are the equations you can use in order to solve the problem. So I'm going to write the Suvat equations. The first is S, it's 1/2 of acceleration t squared plus initial velocity times time. Second, velocity is going to be initial velocity plus acceleration times time. Third will be square velocity equals square initial velocity plus 2 times acceleration displacement. And finally, displacement is 1/2 of the sum of the velocities and time. Okay, these are the Suvat equations. So I'm going to use numbers 1, 2, 3, and 4. Okay, and what I'm asking to have are the unknown that are B and S. Look at that in this case, for for a reason we have the ones that are in first, but sometimes it's not. Sometimes you have to solve the equation for the unknown. And now just go and check what will be the best equation you can use in order to solve the situation. So for example, I'm not going to use equation 4 because I have this that is unknown and this that is unknown. So I'm going to use equation 4. I cannot use equation 3 for the same reason. I have 2 unknown. So I wouldn't be able to do it. But, however, I have the information for equation 2 and for equation 1. So I can use equation 1 and 2 to find the answer. So, for example, I can use equation 1 to find the displacement. So displacement will be a half of at squared plus ut, but I have all the values. Just to remember something that I forget, sometimes I forget it, I remember when I'm writing the equations, remember that this is negative, right? Because it's going down. So I'm just going to write here minus 1/2. Okay, I'm going to be like very strict. Minus 9.8 meters per square second times 3.0 seconds plus 2.0 meters per second times 3.0 seconds. This is to the second power, right? Okay. Now you just need a calculator to compute this, okay? So you're gonna have displacement equals to, and I'm going to have a calculator just to determine the value. So 1/2 times 9.8 negative times 3.0 to the second power, that will be negative, plus 2 times 3 is just 6 times 6. So my answer gets me 38.1, okay? 38.1 meters. Okay, look at that, I'm using SI units because if I use SI units, I'm going to have an advantage in any answer because I will know that the answers will be in SI units. Okay, so that's very important that you try to always keep the SI units because this is going to be an advantage for you. Okay. Here we need to remember that even though the answer is 38.1 meters, we have to round because we just have two significant figures on each value. Look at 2, 2, 2, and 2. Okay? So we have to round using two significant figures. Okay, so the answer will be 38. 38. Okay, it should be negative 38. Okay, the displacement is negative. And finally, to find the velocity, we're going to use the other equation that will be B equals U plus AT. So we use B equals 2 meters per second plus minus 9.8 meters per square second times the time that it was 3 seconds. So I just need to multiply this to get okay, I'm gonna do it by hand. 3 times 8, 24. 3 times 9, 27, and 2, 29. And 2.0 meters per second. So I can just simplify this to minus 27.4 meters per second, and that will be rounded to two significant figures, 27 meters per second. Okay, so I have both answers, V and displacement, but the question is height. Height will be the negative of the displacement, so the height will be 38 meters. So height equals 38 meters. Okay, so to fulfill this information, we need to have a height of 38 meters. So we send it from a building. You know, 38 meters is a building. And it reaches a velocity of 27 meters per second. That it's pretty high. Okay, 27 meters per second, it's pretty high velocity. And this is how you solve problems using Suvat equations. Suvat equations is highly used in exercises that requires evaluation, for example, of accidents. Some accidents, you can see what happened when it crashes, who stopped first, who pressed the brakes first, that stuff. So this is why people use Suvat equations. I hope that it was clear the process we use in order to solve Suvat equations. Always first, write Suvat. Remember S displacement, initial velocity, V velocity, A acceleration, and T is time. Just write which data you have, and finally apply the Suvat equations in order to solve the problem. So I hope that it was clear. Remember to subscribe to my tube for any question, comments, anything. I will be ready to answer for you. So have a nice day and see you in the next video. Bye bye.